Hey folks, welcome back. Today we're going to be taking a look at interval notation and domain and range. First off, we're going to be talking about writing domain and range in terms of interval notation. Now, please understand that's going to be the emphasis, and this is something that you're going to be running into not just for the purposes of this class, but also moving on. And we're going to be evaluating functions and finding x and y intercepts, blah, blah, blah. Oh, wait, we still have MathXL for you to do this evening. So, well, or if not this evening, then hopefully sometime in the very near future. So let's dig into an example. First thing I'm going to mess with is the concept of interval notation. Now, interval notation is to represent solution sets. What I need to emphasize on this is that parentheses indicate that the endpoints are not included. So going back to I don't know, elementary, middle school stuff, if you're talking about a number line, we would say that we have an open dot. An open dot would be that endpoints are not included. Okay, if you've got an open dot, that means that it's not going to be including that. And we're going to be using parentheses when we're doing that. Next up, we're going to talk about brackets, which are these here. When we're using brackets, that's going to be when I have a closed dot. Closed dot. Okay, and hopefully that's not a big to-do. Now, if you end up having something where it goes to infinity or negative infinity, we are always going to be using parentheses when you have something going to infinity, or thinking about in terms of if it was going off the graph one way or another. Okay, so what we're going to be doing is we're going to be talking about some examples, things that you've seen before and hopefully are familiar with. But what we're going to do is we're going to translate this into interval notation. Now, the big difference is that you guys are probably fairly familiar with inequality notation or something like that. We're going to transfer this into interval notation because, again, this is sort of a next step up when we're going to be interpreting things. So let's take a look at what I've got here. You're asked to express each solution set in interval notation. Please understand that I know that most of you would probably write this and say -4 is going to be less than or equal to x is going to be less than 3. And we're going to say, well, that's correct, but I'm going to try and wean you off of this. We're going to use what's called interval notation. And we're now going to say, well, it goes from -4 up to, but not including -3. Again, I'm using a bracket here because it's a closed dot, and I'm using a parenthesis for this position because it's an open dot. Okay, that's not too terribly difficult. Let's take a look at this one here. Again, if you were to look at this, I'm assuming you could do the inequality set, but what I'm going to do is I'm going to try and do it as an interval notation. And so I'm going to say, well, in this case, I'm going to be going from -1 to 5 is my defined area. Again, what we're trying to do is we're trying to come up with a way of writing this so that A, we're doing a little bit less writing, and more importantly, you're saying where things work. So I'm going to say, well, this symbol here tells me it's an open dot, so I'm going to have a parenthesis. This symbol here is a closed dot, and so I'm going to have a bracket. So that's how I would write that. Let's move on to another example. This one here. Now, you're seeing the arrow at the end, and I'm going to say, well, my lowest value starts at -2, and it goes up to, well, it just keeps going. It's going off the graph. So what we say is we're going to write this as going to infinity. And once again, I have to identify open or closed dot. It is closed, so I'm going to put a bracket. And because it's going to infinity, infinity always will be a parenthesis there. Okay, still pretty good, I'm hoping. I'm going to let you guys copy this down. You could pause this video for a second if you need to. How would you write this? Okay, the reason why I'm going to do this one is most people would say, well, it's going up to 1. And where is it going from? Well, it's going from negative infinity to +1. Now, I do want to take a quick second. I haven't specifically said it, but in each of these cases, I'm going from the low up to the high. You always go from low to high. The lowest value, comma, highest value. And hopefully that'll do things there and make things fairly comfortable for you. All right, let's keep moving. And we're now looking at this one. Now this is a compound. So we're going to need to write two different expressions. So in this case, I'm going to say, well, I'm going from lowest value here is negative infinity, and I'm going up to a -2. But, I emphasize the but very carefully, that's a closed dot, but I'm not done yet. Well, it's a closed dot, so I'm going to make sure that I've got there a lovely bracket, and I got a parenthesis here. And then I'm going to say, well, the lowest value, kind of using this arrow, is going to be going from 1 up to infinity. And again, it doesn't include the 1, so I'm going to say it's a parenthesis. Now, I have two different domains. Both of them are legitimate, but I need to emphasize that they're both legitimate. And what you do is you tie those together by putting the U. Now, that's called the union. I'm not going to explain what union means yet. We'll get into that a little bit more second semester, but please see what you can do about doing something like this next one here. Okay, give people a couple seconds. Pause the video. You can copy it down and see if you can come up with the answer. Okay, I'm hoping that you're done, so I'm going to say low end going from negative infinity up to, but not including, -1. And then here I'm going from 4 to infinity. Now again, anything that's infinite is going to be getting the parenthesis. And since they're both open dots, I'm going to put that there. And so now I slap the U in between, and we're not even getting into the technical math setup, which is x is an element of that. Don't worry about it. We're not going to spend the time doing that. Next, finding domain and range from a graph. Now, again, it's the same rule as a number line. It's just that we have to be a little bit more careful on things. So I'm going to say, when we have a closed dot, we say that that point is part of the graph. And I'm hoping people are okay on that. And once again, if I have an open dot, that means that that doesn't belong as part of the graph. So let's see what we can do. And oh wait, if I have an arrow, that indicates that the graph extends infinitely far in that direction, in whichever way the arrow is pointing. Once again, please copy that down. Pause this if you need to make sure you've got this someplace in place. Next. Okay, and here we go. So I'm going to pull down, and you're going to see an example here of what is being talked about. Now, the problem is a lot of people are usually pretty good on the concept of the domain. You're saying, what x values do I go from and to? And so I'm going to say, in this case, I'm going from this lowest x value up to this highest x value. But it's going to be the range, especially on something like this, where I'm going to have people getting confused. I'm going to have people say, well, I started down here, but I went up to there. And they say, that's my range. And I'm going to say, no. The key thing about range is what is the lowest value you see up to the highest value you see. Okay, and in both these cases, I've gone from that low to that high. So my range are going to be all of the y values that the function takes on. So again, pause if you need to, and let's see what we can do about clarifying this. Okay, we're now going to go to a couple of examples of actual graphs. Now, I'm hoping that these will come fairly easily. Some of these early ones should be fairly easy. But when we get into some of the more complicated graphs, I expect people to take a little more time and be a little bit careful. Okay, so we're looking at this and we're going to say, well, what's the lowest x value that I go start off at? Looks like I've got my lowest x value is here, and it goes from -3 up to 2. and I look for my y values, and I say my y values go from, looks like a -5 up to a +5. So when it comes to evaluating this function, you should end up with some values that look like, write it out here for you. I'm going to be going for my domain goes from -3, because it includes that -3, it's a closed dot, up to +2. And my range is going from a -5 up to a +5 there. Again, notice I use brackets because it includes both sides. All right, we're going to go back on this one, and we're now going to say, well, what is my lowest x value? Well, it sure looks like it's here around -6 and goes up to 0. But notice I drew that as an open dot. The reason why? Because it is an open dot up here. So I can't include -6, so my domain will be running from -6 to 0. But I'm going to have a parenthesis here, and it definitely includes the 0. Let's take a look at the range. My range is going from, let's see what I've got here. My range goes from, on the low end, looks like it goes from -3 up to, but not quite including 4. So when it comes to be time to write this out, I'm going to say it goes from -3, comma, 4, because that's kind of the range we're talking about. It includes the -3, but it certainly doesn't include the 4. Okay, people still good on that, I'm hoping. All right, let's take a look at a couple more and see what we've got here. Next graph. Again, you should be able to come up with a quick sketch of this and see what you can do about coming up with the domain and range. Okay. And I'm going to say, all right, well, let's see what's happening. The key to notice here is this arrowhead. It continues onward. Let me change it so that the color is something they'll actually show. This is going on and on forever. And this is going on and on forever. So therefore, I'm going to say, what is the lowest x value? Well, since this continues on in that direction, that means that my x value has to go on and on and on and on forever. And my positive x value is going to be going on forever and ever and ever. So my x coordinates, it looks like it's going from infinity to infinity, or negative infinity to positive infinity. And I'd say, yep, that sounds about right. But let's also take a look at my range. Sorry about that. My range goes from, what is my lowest y coordinate here? Well, it looks like it has a y coordinate of 1, and then it just keeps going up there. So when it comes to writing out my notation, I'm going to say my domain is from negative infinity to positive infinity, and my range goes from 1 to infinity. Okay, please take a look at this one and see how you would interpret that. Pause the video if you need to. Okay, moving on. Again, notice the arrowheads. It's continuing onward. Now, it means it's going to just keep going on and on and on. So I'm going to say goes infinitely far that way and infinitely far that way, which should be giving you a clue that my domain is going to be negative infinity to positive infinity. But again, my concern is not where things are going at the end. My concern is what is happening in terms of my y coordinates. What is the lowest y coordinate I'm messing with? It looks like it's down here at -4, and that's a closed dot. And it goes, well, infinitely far that way. So I'm going to say it's a closed dot, so I'm going to go bracket -4 up to infinity. Okay, hopefully this is making fairly decent sense. And at this point, I'm now going to change gears and let's go to a couple more examples and see if this might help some people to see things. Okay, once again, please see what you can do on your own and see what you can come up with in terms of values. What is my domain? What is my range? Again, pause the video and check yourself. Okay. And since we're not wanting to spend the entire time, I'm truly hoping people are looking at this graph and you're saying, clearly, my x-coordinate starts here and goes to there. Except, what is that lowest x-coordinate? That's 0. It goes up to, but doesn't include 5. So I'm now going to say that that's going to be working from 0 to 5. What about my range? Well, my range in this case is going to be doing something fairly similar. And let's see what we can come up with on that. Lowest y-coordinate goes from -1 up to, but not including 5. So I'm now looking at my expression is going to get me that there. Okay, cool on that. A little more of an interesting graph here on 6. I'm going to say what's happening. I'm truly hoping that people at this point notice arrowheads on both sides, pushing it off to -infinity, +infinity, and are cool on that. And then we're going to say, well, what is going on with my y-coordinates? Now, most people will recognize that the highest it ever gets is -2. And what does it do past that? Well, it ends up going down. Now remember, we're going to start with the lowest y-coordinate and then go up from there. So I'm going to say in this case, my graph is going to go from -infinity up to -2. Once again, noticing that I do have a bracket here because it includes that point. Okay, let's take a look at, say, one more of these, one more pair here, and we'll see where it takes us. Okay, again, these are nice sketches. And again, if you want to do your best to come up with a basic sketch of this, wouldn't be a bad thing. And we're going to again ask to find what is my domain and what is my range. What is my domain and what is my range? Okay, well, looks like my lowest x-coordinate is at -1, and it goes on forever. So I'm going to say, it sure looks to me like I'm going from -1 to infinity. And this one, the lowest y-coordinate, I'm going to say is at 0. And once again, because that arrowhead indicates it's going upwards, I'm going to say that that is going to get me from 0 to infinity. So that when I'm looking at this, I'm now going to be looking at going from -1 to infinity and from 0 to infinity. Now, let's take a look at one that may be a little bit more challenging for some of you. I'm going to say, where do my x-coordinates lie? They start here, which is a closed dot. They go up to here. Again, always going from left to right. So I'm going to say it goes from -5 to +5. And since it includes both of these, I'm going to say brackets on both sides. But I'm also going to take a second and I'm going to look at what do my y-coordinates go from? Well, they're going from a -4 to a +4, from low to high. So I'm now going to be saying that I've got from -4 to +4 there. Okay, so hoping that that will cover what you need to see on those. Now, what happens if you've got a little more of an interesting problem? Something like this. Okay, given this graph, see if you can answer the questions. And once again, feel free to pause this and take a look and see if you can answer all of these questions. Okay, and I'm assuming the pausing is done. So we're going to move on and see where we can do. It says my domain. Well, since I see an arrowhead here and I see an arrowhead here, and they're both indicating that they're going off the graph, I'm going to say -infinity, +infinity. Next, I'm going to take a crack at my range. And I'm going to say, what is the lowest y value I see here? That's down here at -4. And it is a closed dot, so I'm going to say -4 up to infinity. So doing that there, just like that. Next, x-intercepts. I've got to tell you, this is one of those things where it's not my pet peeve, but many of the people I teach with, this is kind of their little pet peeve. If you had a teacher that taught you to just write what the number is where the graph hits the x-axis, you're going to lose points. So I need to emphasize, always write both x-intercepts and y-intercepts as ordered pairs. Not so much for me, but because many of the people that I teach with are downright particular about this. So I'm going to say, well, where does it hit the x-axis? Sure looks like it hits it there and there. So writing it as an ordered pair is going to be 1, 0 and 7, 0. This has been so much of a thing that I can tell you right now, people have been trying to fight about this, and I'm just trying to make your life a little bit easier as you continue on math-wise. All right, back into this next one, the y-intercept. Where does it hit the y-axis? Up there. So I'm looking at 0, 4. All right. Last two, and I would emphasize, please make sure you're paying close attention on this. You're asked to find f of -3. Now this is applying stuff from, well, the previous lesson. Remember, all this is saying is, what is the y-coordinate when I substitute in -3? So in other words, here's -3. What's my y-coordinate when I hit the graph? Well, I'm hoping people are going to say that that's going to be 4. Again, this is one of these things that people, if you're not really paying attention, this would be something I would copy down. That's one that's going to show up again and again. This is function notation, and this will keep popping up. The last question is a little bit of a backwards version of function notation, so please make sure that you interpret it correctly. The value of x for which f of x is -2. So what it's saying on this is, where or for what x values am I going to have a y-coordinate of -2? So I'm going to say, when y is -2, what do my x values have to be? And for some of you, it's worth it just to draw this little line in to indicate that I'm looking at an x value of 2. In other words, it's hitting there, and it's also hitting there at 6. Okay, now, at this point, I am assuming that you have been listening to me talk for quite some time, and that you're probably ready to see what you can do in terms of the Math Excel. I'm going to let you go on that, but don't be afraid to ask me questions about things in class the next day. We'll have a couple more examples to mess with then. All right, have a lovely one, and I will talk to you guys a little bit later on.